My homemade engine right here is the result of over a year of continuous progress and improvement, but there's still a lot to do to it. So let's jump right into it. The first thing I'm going to do is cast an aluminum crankcase, as last time it ran, it actually melted the crankcase. Got aluminum melting down in the forge right now. Just waiting on everything to get done melting, and I'm going to cast the crankcase. The casting turned out pretty good. The bottom of the casting was not packed good enough, so I got some bumps and stuff. But I'm going to sand this down nice and flat, and I got a new tool at my disposal that I'm going to use. Alright, right here's the new tool I got. This will help a lot. Okay, so here I'm making this side of the crankcase parallel with that side of the crankcase. In order to drill the holes on the top of the crankcase, I just real quickly made some engine mounts so that I can actually hold the crankcase level. Alright, now it's time to cast the crankcase front and back plates. So I 3D printed out this mold and I'm going to sand cast it out of aluminum. Alrighty, so right here are the front and back plates for the crankcase. I casted out 2 of them for the front and back, and all that's left to do now is machine them down. Alright, so if you look right here, I need to remove that because the front of the crankcase will have to cover that. But if I go back to here, this is stopping me. So I'm going to have to remove this manually. Right here are the front and back plates test fitted on the crankcase, and everything seems to be going good. There's a few spots of hits that I have to clean up with a Dremel, but everything looks good so far. Alright, let's give this a cleanup. Now I've got to file this down so the connecting rod can get through it. Now, I finished up most of these bolt holes already because these ones need to be very precise, so I wasn't able to film it, but let's finish up the backside. Last one. And boom, there we go. The crankcase is pretty much completely done. Now, there's a few things left for me to do. I have to put an oil fill hole in here, fill in this with JB Weld, and make something so the bolt holes aren't going in at an angle. Now, for the oil fill hole, I made this thing on my lathe, but I have to finish it up. Let's tap a 5/16 thread on it. There we go. Now I tapped matching threads into the crankcase so that it can thread in. If you remember from my last video, the crankshaft was actually a little bit too light with the new aluminum piston. So what I did is I added a 1/4-inch plate onto there and welded it on, so now it should be good. Also, now that I have a left-hand carbide tool cutter, I'm actually going to be able to machine the flywheel down so it's perfectly straight and doesn't bounce. While I was at it, I decided to polish it up as well so it's nice and smooth. Now, to make sure that the cylinder bolts stay straight in the crankcase, I decided to try casting these pieces out of aluminum, but I wasn't really sure if they would work. So, I quickly made one up, and they work really good. So let's make one more. And there we go. I'd say that turned out pretty good. Now, I'm going to fill in these gaps with JB Weld. That looks pretty good, so now all I have to do is sand it down. That looks pretty good there. Now all that's left to do is torque up the flywheel nut to 40 foot-pounds. There we go, 50 foot-pounds. Now that the crankcase is completely finished, let's assemble everything.
Yeah.
Now, if any of you guys like fishing, I would highly recommend checking out the Marathon Sport Fishing YouTube channel, as he does some crazy stuff over there, like catching swordfish all by himself. Now that the engine is all assembled, I'm going to be doing a quick test run to make sure everything's working correctly. And after that's done, I'm going to redo the valve train. Alright, so the engine is set up and ready for the first test. Alright, let's see if it does anything. Or maybe it doesn't have spark. No spark, huh? Alright, just got the battery charger set up. Let's see if it has spark now. Yep, it does. Well, I know the crankcase works, that's for sure. Jeez. You know what? It's not running away. I'll take that as a win. Whoa! Ooh, that's a lot of RPM. Oh my god. Oh my god. Oh, we lost compression. Well, I found out why we lost compression. It literally pulled this screw out of the head. Another thing that's crazy about this is I was totally expecting it to leak oil. There is not a drop of oil that leaked out. Even though there's no oil seals, there's not a single drop of oil. Alright, well, let's see how the oil actually does look. It didn't leak oil, so that means it drank most of its oil. And this is how much is left in there. Well, when I make a new piston for the engine, I'm definitely going to have to add an oil ring, and that oil does not look very good anyways. As you can see, the engine is disassembled again, but that is because I'm going to be static balancing the crankshaft. Alright, let's find the reciprocating mass of the engine. 45 grams, 222 grams, 35 grams. That gives us a total reciprocating mass of 302 grams. Then I just added weight until the crankshaft stays where I put it. Now we see how much weight it took to balance the crankshaft. 107 grams. That gives us a total balance factor of 50.3%, which is actually just fine. So that means that either the engine is spinning faster than I estimated, or I need to soft mount the engine by putting some rubber plates under the mounting plates. Now that the bottom end of the engine is done, let's start work on the valve train. I've 3D printed out all these parts, and now all that's left to do is sandcast them. Right here is all the parts, so now what I have to do is machine them down. Because I had the head almost completely apart, I decided to resurface the face where the intake manifold bolts on so that hopefully I don't get any more intake manifold leaks. Then I went through with an angle grinder and ground all these flat so that the bolts have a nice flat surface to sit on. Now, the last thing I'm going to be doing to the head is I'm going to be drilling out these holes for a 5/16 bolt, and I'm going to put it in through the bottom so it acts like a stud. There we go. I'd say that turned out pretty good. Right here are the new aluminum valve spring retainers I made for my engine, which have threads in the top and set screws in the bottom to hold it in place, but you can't have aluminum pushing on aluminum. So these brass pieces that I made will be JB welded on top and machined down. So apparently JB Weld isn't strong enough to hold it on there, so I've replaced it with some super glue and I'm going to see if this works. Now, since super glue breaks down at around 150 degrees Fahrenheit, I'm going to have to find some other way to hold this on there when the engine warms up. Alright, so I drilled 2 holes into this piece and put little pins that were coat hanger wire, and now I'm going to smash them down. I'd say they turned out pretty good, and they also look really good as well. Now, with the engine all assembled, I realized we have a very big problem. Right there is where the exhaust valve starts to open, and there's where the crankshaft is. Right there is where it closes, and there is where the crankshaft is, which means my engine has 360 degrees of duration, which is absolutely insane. That means that I have to file a ton of material off of the lobes, so I will come back to you guys when I'm done. Now with the camshaft looking much better, it's time to test it. The engine is officially ready to test. For some reason, the engine would only run in short bursts like that, so I took some slow motion shots to see if I could figure out what was happening. I don't know. It seems to be an issue with fuel delivery. Now, I kept having issues with the ignition module melting, so what I did is I made some spacers out of wood for either side so that wood is a really good thermal insulator and hopefully it doesn't melt. Alright, I got the wood washers on there. Let's see if it does anything. Now, the engine actually ran pretty good. We got a runtime of just under 5 minutes, which means that I'm going to have to put at the end of the video so that you guys can watch it if you want to, because it's so long. But I'd say the engine ran pretty good. The only issue we had is this thing literally melted. Alright, let's see what the oil looks like. Ooh boy. Alright, well there's what the oil looks like, and there's not a lot left. Now, with the engine back inside the house, there's a few things that I want to talk about. The first thing is, I don't see much of a point in pursuing this design. First of all, the head is a terrible combustion chamber design. It's just flat like a diesel, and I have a lot of leakage through the intake valve stem, so that's why it's being very difficult to tune. The other thing is that I don't have a good piston there. There's no oil ring, so it burns a ton of oil. Now, I'm sure you guys will want to see a teardown and see what the inside of the cylinder looks like, so let's take the head bolts off and see what it looks like on the inside. Well, this is not ideal. Where'd the top teeth go? I'd say the cylinder looks really good. There's a few score marks that are up and down, but nothing that's any severe. And also, the cross-hatching is still visible. Now, I think I'm pretty satisfied with this engine. One of its biggest problems is that because it's a single cylinder, it inherently has problems with getting good balance. So I'm actually currently looking into building a homemade 550cc inline 2. But if you guys would like to see me continue working on this engine, let me know down in the comments and I will do that. But in the meantime, make sure to subscribe and leave a like, and I will catch you in the next video. Thank you for watching. was a pretty good run. We got almost 5 minutes of runtime there.